a scientist in the US, with a group of 32 5-month-old infants in 1992. Let us see how young Varney reacts to the same stimuli. She is first shown a doll that is then hidden behind a screen. Then another doll is added to the one behind the screen. Now if Varney sees a number she expects, she does not react. So if there are two dolls behind the screen, which is the possible event, there is little reaction. However, if there is a number that she does not expect, she clearly notices. So if there is one doll behind the screen and she hadn't seen the second being removed, she would be surprised. How do we know that she has noticed? Well, because she looks at the objects for much longer. Similarly, if there are two dolls to start off with and one is removed, Varney is able to perceive the difference between the right answer and the wrong, which implies that infants are capable of distinguishing between small numbers. This result caused much consternation when first published and had many disbelievers, but independent research from other sources have confirmed Wynn's findings. Great. So it looks like humans and animals both have an innate number sense. But as mankind progressed, what they developed was a numeral system to make sense of these numbers. We'll need to travel to ancient India and explore the mathematics of this region. So what kinds of numerals were used in India? Some early evidence is found in columns erected in India by King Ashoka in about 250 BC. Similar inscriptions are found in caves near Pune, 100 BC, and Nasik, 200 BC. These numerals appear in a script called Brahmi. The Brahmi script, which are notations for numbers 1 to 9, as well as distinct symbols for a host of other numbers. However, what they didn't use was a zero. One important source of information on this topic is the writer Al-Biruni. Al-Biruni, who was born in modern-day Uzbekistan, came to India first in 1030. Through his numerous visits, he studied and documented the Indian number system. He realized that number systems often varied across different regions. For example, the Tamils in the south of India had also evolved another numeral system, the Tamil Brahmi numbers. Various stone inscriptions and pots show evidence of this, and most of this inscription dates back to the 1st and 2nd century AD. Now all these numbers eventually evolved into what came to be known as the Indo-Arabic numeric system. Let's explore how the system works. It has 4 defining characteristics. First, it uses 10 digits, 0, 1, 2, till 9. It groups these by 10, so 10 ones are replaced by 10. Similarly, 10 tens are replaced by 100, 10 hundreds are replaced by 1000, and so forth. Thirdly, it uses a place value, starting from right to left. So the first number represents how many ones there are, the second number represents how many tens there are, the third how many hundreds, and so on. So if we have 22 crayons, we will group 2 groups of 10 and we'll have 2 left over. We will write 22 like this. If we have 124 crayons, we have 1 group of 100, 2 groups of 10s, and 4 singles. We will write 124 like this. Finally, the system is additive and multiplicative. So if we take 124, the value of the numeral is found by multiplying each place value by its corresponding digit and then adding the resulting products. So the numeral value is equal to 1 into 100 plus 2 into 10 plus 4 into 1. 100 plus 20 plus 4, 124. It all sounds pretty simple and obvious, doesn't it? And that is exactly the advantage of the system. It makes maths simpler. How about zero? India was clearly familiar with the idea of zero. Let me give you some evidence. For that, we need to travel to the fort at Gwalior. Well, there is a stone tablet to the Gwalior fort that dates back to 876 AD. Now this tablet is a notation for zero. Not once, but twice. It mentions a piece of land that is 270 by 187 units long, and in the number 50, which refers to a daily gift of 50 garlands. This is the first recorded evidence of the zero we use today. Though some believe that Indian mathematicians like Aryabhatta and Pingala knew about it earlier. In fact, the Indian mathematician Brahmagupta also talks about zero. He writes that when you subtract a number from itself, you get zero. He added, the sum of zero and a negative number is negative. The sum of a positive number and zero is positive. The sum of zero and zero is zero. Now what made India's contribution revolutionary is the use of zero as a number rather than just a placeholder. This combined with the other numerals hugely simplifies all arithmetic operations. This knowledge traveled to Arabia, which was a huge center of learning at the time. When the famous Persian mathematician Al-Khwarizmi studied the system, he immediately saw this could revolutionize mathematics. Al-Khwarizmi was swift to take all these foreign symbols and ideas into his heart and mind and make them his own. His book, Kitab al-Jam wal Tafriq bil Hisab al-Hind, or Hindu Art of Reckoning, played a big role in spreading these concepts. This system then moved to Africa. A young mathematician called Fibonacci was exposed to this system as he lived in North Africa. He received an education from English teachers. He realized that Arabic merchants were able to calculate much faster than their European counterparts, and realized that this was because they were using the Indo-Arabic system of numerals, which was clearly more efficient. Fibonacci quickly realized the advantages of this new system. When he returned to Pisa, he wrote a book that he finished in 1202, titled Liber Abaci, meaning Book of Calculating. This book dealt with the methods of arithmetic in the decimal system, and it eventually persuaded European mathematicians to drop the old way in favor of the new. These two systems led to a divide in Europe. In fact, there used to be mathematical competition between the two. On one side, there were the Abacists, who used an abacus, and on the other, Algorists, who used the newer Indo-Arabic systems. There's a 14th century manuscript of Boethius's The Consolations of Philosophy. There appears a well-known drawing of this kind of competition that is being judged by the goddess of numbers. Now Europe at this time was using the Roman numerals. So if you need to write the number 1999, this is how it would look. Imagine adding and subtracting from this. Much easier to add from 1999, right? Now we know who finally won. By 1500 CE, the newer Indo-Arabic system had won, and has persevered until today. The best way actually of seeing who won is by exploring the systems used today, anywhere in the world. China, Arabia, Africa, Venezuela, languages, font, metaphors change, but the number systems are truly universal. That's all we have on numbers today. Keep watching the Maths Factor for many other interesting nuggets on the magic of mathematics.
in this episode you saw that how earlier times there were different kinds of number systems, not just only the thing that we are familiar with. Of course, we are also partly familiar with what is called as Roman system. Suppose if you are writing 5th standard, you write V like so for writing V, but we don't use it for calculation, though we are sort of familiar. But there were a number of systems. Okay. But the number system that evolved in India has become kind of universal. I mean, if you go to China, the people may speak in Chinese, but when they write number, they write 5 in the same way. Okay, the way we write. Okay, you go to Africa, you go to your market, if the price is hanging, okay, and the price is, let's say 20 something, the 20 will be 210. The 210 that we are familiar with. So the maths has become universal, or the math script, or what we can call as the notation has become universal. The writing of maths has become universal. It has become universal because this is a very powerful system. You know, I mean, you can add, subtract much easier than any other system which have been devised by others.
आज अभी दूसरी फिल्म में आपने ये देखा कि जो हमारे देश में एक नंबर का सिस्टम बना, वो कैसे दूसरे देशों के बने हुए सिस्टम से बेटर था और धीरे धीरे सारे संसार में फैल गया। जीरो की बात, स्थानीय मान की बात, और उसको स्थानीय मान को किस प्रकार से इस्तेमाल करते थे, इस बात सारी बात को जब हमारे देश में डेवलप जो संख्या पद्धति ये बनी, संख्या लिखने की पद्धति बनी, उसको किस प्रकार से दूसरे देशों ने जब देखा कि अरे ये तो बहुत आसान है, बहुत अच्छी है, तो उन्होंने अपना लिया। और इस समय जो पहले कभी इंडो अरेबिक सिस्टम कहलाता था, वो इंटरनेशनल सिस्टम बन चुका है। आप किसी देश में भी जाएं, वहाँ पर नंबर लिखने की पद्धति यही है, उसमें फर्क नहीं आएगा, भाषा कोई भी फर्क हो सकती है।
Yeah, also another interesting thing that in this film you saw is young human babies, less than even 4 months, 5 months, have a number sense. That is, they will be able to distinguish between 3 and 4. They will not be able to distinguish between 100 and 105. That is very difficult. But if small numbers, you know, less than about 7, 8, they will be able to distinguish. Similarly, a large number of birds, bees, and other animals are also able to distinguish between small numbers. That is, they can distinguish between 3 and 4, 4 and 5. Okay, they will not be able to distinguish between 50 and 55, or 50 and 52. Okay, that's a bit difficult. But even monkeys, there is one experiment which we have not shown in this film, where they have shown that the monkeys can actually distinguish less than 10. I mean, numbers, discriminate between less than 10. So if monkeys can learn maths, we should be able to learn maths.
नहीं, क्लास 1 के बच्चे भी, मेरा अपना अनुभव है, जब मैंने क्लास 1 के बच्चे से पूछा, बच्चे तुम्हारे हाथ में कितने हैं, उसने कहा 3। मैंने कहा तुमने गिने तो हैं ही नहीं, कहेंगे मुझे पता है ना इसमें 3 है। मतलब they can perceive the numbers up to 5. I've seen this happening in class 1 easily. The children are able to perceive the numbers up to 5 without even counting. They will just take and they say they will, it is 4, it is 2. तो अभी आपने देखा कि कैसे जानवरों में और बच्चों में भी एक नंबर सेंस हो कि नंबर को पहचानते हैं कि कम है, ज़्यादा है। वो नंबर छोटे छोटे हो सकते हैं, मगर उनके अंदर एक पहचान होती है कि नंबर वही है या उससे ज़्यादा।
Anybody wants to ask some question or comments or anything that you did not understand, you want a small explanation, you can certainly do that. And if you want copies of this program, you can